Hi, this is Miss Holtz, and in this video I'm going to be talking about projectile motion. So we've talked a lot about vectors and how to use math to manipulate vectors, but we haven't applied it to physical situations yet. So we're going to use projectile motion as the situation where two-dimensional vectors are applicable. So let's define a projectile. A projectile is an object that only has the force of gravity acting on it. So in these cases, we're not going to care about air resistance. Air resistance will always be neglected in terms of a projectile. We also know that projectiles travel up and down or in a parabolic path. So if you think about these scenarios down here, we have somebody dropping a ball straight down. And so in this case, our projectile is moving in an up and down type of motion, in this case down. You could also think of a projectile as being thrown straight up into the air so that it goes straight up and then straight back down. Or you could think of someone throwing this ball at an angle so that it goes up and kind of to the side and comes back down. And this shape right here is called a parabolic path. Or if you were to graph this shape, it would be graphed using a quadratic equation. So here we have an object that's being thrown through the air, and this is its point in time. Each one of these little dots here is a point in time during its motion. And so we said that a projectile has only the force of gravity acting on it. So it only has this free body diagram at all points during its motion, because the only thing acting on it is gravity. And even if it does have a little bit of air resistance, it's not enough to make a difference. So we consider it to only have the force of gravity acting on it. Now, what's confusing sometimes is you think of the object, the ball, as the projectile. But what about when that ball is being thrown, at the moment it's being thrown? So if we were to draw a free body diagram for that ball right as the person is throwing it, it does have the force of gravity acting upon it, but it also has an applied force from the person throwing the ball. So in this case, right in this instant, this ball is not a projectile. It's not a projectile until it's free falling in the air and it only has the force of gravity acting upon it. Now, let's talk about this in terms of inertia, or Newton's first law, the law of balanced forces. So here we have a cannon that's launching a cannonball, but in this scenario, we're imagining that there's no gravity. Gravity doesn't exist. So as soon as this cannonball is launched and it's just flying through space, open space, it has no forces acting on it. So its free body diagram is just going to be a box. There's absolutely nothing acting on it. The forces are balanced. And so it's going to continue to move. An object in motion will continue to go in motion as long as the forces are balanced. But what if we add gravity into this scenario? When you add gravity, your free body diagram includes this force of gravity right here. And forces cause acceleration. So what the force does is it causes the cannonball to accelerate this way. So it's not only changing its speed, it's speeding up as it goes down, but it's also changing its direction. So it's no longer going in a straight path, but it's going along this parabolic curve. So I hope that gives you a better understanding of what a projectile is.